Good morning, ladies. It's Mr. O'Sullivan. Today we're going to be looking at lesson 2-8, the Pythagorean Theorem. If you watched the YouTube video for this lesson already and you had missed the Zoom and you were watching a portion of it, you might have realized that there's sound missing for a portion. It's because the New York City Department of Mental Health and Hygiene called me to do contact tracing. And my iPad synced to my iCloud, so I got the phone call in here, and then I declined the call because I called them back on my phone, and yada yada yada. The audio went missing for a good portion of this video, so I'm going to restart it. So bear with me. Today's learning target is I can apply the Pythagorean theorem to determine the value of a missing segment length on a right triangle. That's actually a very important thing, the right triangle. It can only be used on right triangles. I was actually having a conversation with my sister about this a few weeks ago because she's currently in the Navy for med school. Well, she graduated med school, but now she's in the Navy. And she had to take a test on something. I forget what it was. And she asked me if the Pythagorean theorem can be used for non-right triangles. And I was like, no, it can only be used for right triangles. Apparently, there's some people in this world who think that the Pythagorean theorem can be used on non-right triangles. So here's the theorem. If a triangle is a right triangle, then the square of the length of the longest side is equal to the sum of the squares of the lengths of the other two sides. In this case, we call them the legs. In other words, you've seen this before. My Pythagorean theorem is just a squared plus b squared equals c squared. Your hypotenuse is going to be c, and your legs are a and b. So I'm going to go to my image and label my legs. Here are my legs. It doesn't matter where I put them as long as they're not in a specific spot. Here is my hypotenuse. My hypotenuse is the side across from my right angle. And I'm giving you the heads up. The hypotenuse is the largest side of your right triangle as well. Think of like a hippo, like a hipponoose. The hippo is one of the largest animals in the world. So it makes sense that the hypotenuse is the largest side of your triangle. Now let's go on to some examples where we actually see the Pythagorean theorem play out in the real world. So if I want to find the length of this missing side, the first thing I have to do is ask myself, is it a right triangle? Well, yes, it's a right triangle. So I can use the Pythagorean theorem to find my missing side length. So the first thing I do is I rewrite the Pythagorean theorem. So a squared plus b squared equals c squared. And I now need to ask myself, what are my legs? What are my hypotenuse? Well, I know my hypotenuse is across from my right angle. So here's my c, and here's my a and my b. It doesn't matter if you make the 45 your a or the 28 your b. It really doesn't matter because you're still going to get the exact same answer. Thing is, I wanted to find my hypotenuse, but I don't know what my hypotenuse is. So whenever we don't know something in math, we either put a question mark or we put one of our favorite variables. In this case, I'm going to put an x. So I'm going to make my substitutions. I'm going to do 45 squared plus 28 squared equals x squared. So now I go to my calculator and I can just do 45 squared plus 28 squared in my calculator. So I'm going to type this into Desmos. Just kidding, I'm not going to use Desmos. I'm going to use my TI-84 Silver Edition. So when I type 45 squared plus 28 squared into my calculator, I get, 2,809. So I get 2,809 is equal to x squared. And remember, the only way to get rid of a square in math, we did this in Algebra 1, is to take the square root of both sides. So I'm going to take the square root of both sides. I'm going to type the square root of 2,809 in my calculator, and I get 53. So I can say that x is 53. And that's basically saying your hypotenuse is 53 units long. We don't know what our units are because it's not specifically labeled in our image. All right, that's the Pythagorean theorem. Now, we're not always given a visual. If we go to the question on the right, it says the lengths of the legs of a right triangle are radical 10 and radical 14. Find the length of the hypotenuse in simplest radical form. So whenever it says simplest radical form, that's a sign that your answer is going to contain a radical. So we're going to have to use prime factorization to simplify our radical. If you know the trick or the shortcut, well, basically it's not a trick or a shortcut, it's just another way of doing it. If you know the other way of doing your radicals, go ahead, but I'm going to do the prime factorization way since that's how 90% of us do it. So I have a right triangle. So the first thing I'm going to do is I'm going to draw a right triangle. And remember, Mr. O'Sullivan has a degree in math. He doesn't have a degree in art. That actually doesn't look that bad. You put in your right angle. And now we know our legs are the square root of 10 or radical 10 and radical 14. I'm now going to label those in my image. So radical 10, radical 14. I don't know what my hypotenuse is, so I'm going to put an x. We know Pythagorean Theorem states a squared plus b squared equals c squared. And now we're going to just do those substitutions. We're going to substitute a radical 10, a radical 14, and then we're going to do an x squared. So I have radical 10 squared plus radical 14 squared equals c squared. X squared, sorry. So now in my calculator, I type in on Desmos radical 10 squared. So I'm going to do that right now, radical 10 squared. And I get 10. So basically, I can say that a number squared under a radical by itself sort of cancels each other out. So I can say that radical 14 squared is just 14. So I have 10 plus 14 equals x squared. 10 plus 14 is 24, so I have x squared equals 24. And again, the only way to get rid of that square is to square root both sides. So I get x equals radical 24. But now I need to do the prime factorization of my 24 to make it simpler. So I have to ask myself, what makes 24? Well, 2 and 12 make it. 2 is prime. What makes 12? 2 and 6. 2 is prime. What makes 6? 2 and 3. Those are prime. So I now put all those numbers under a radical. So radical 2 times 2 times 2 times 3. Double on the inside, single on the outside. So I get 2 radical. What's 2 times 3? 6. And that's your final answer. That's the length of my hypotenuse. Isn't that fun? Now let's go on to our next question. Find the missing side length using the Pythagorean Theorem. So in this image, I'm given my hypotenuse and I'm given a leg. I'm missing a leg. So I label my sides. I have my C, my A, and my B. We don't know what B is, so we're going to put an X. Again, we just write it out. A squared plus B squared equals C squared. A is 9.7, so I have 9.7 squared plus x squared equals 13.3 squared. And we're going to type those out into our calculator. So when I do 9.7 squared, I get 94.09 plus x squared equals 13.3 squared, which is 176.89. I now need to get everything on one side. My x is on one side, my number's on the other. So I'm going to get rid of my 94.09 by subtracting. My 94.09's cancel, and I'm left with x squared equals 82.8. And now, to get rid of that x squared, I take the square root of both sides. So I get x is equal to, 1 second. I get this long, nasty number. I get 9 point. Ooh, this is going to take me a while to write. I'm just going to say it after I finish writing it. Give me one moment. Ooh, wow, that took me forever to write. I got 9.099450533. Here's the thing. Most of the time, we just ask you to round. So we're going to just make this a rounding question. We're going to make this round to the nearest tenth. So we're going to just round to the nearest tenth. So I look at my 0, that's the tenth. Go to the right, it's a 9, so I go up. 5 are high, go to the sky. So x is approximately 9.1 as your final answer. The next problem. Find the area of the triangle. Well, we know that our area formula is base times height divided by 2. I know my height is 4, so I'm going to make that substitution right now. Here's the issue. I don't know my whole base. I have a 4, and I don't know what this is. Well, guess what? I can use the Pythagorean Theorem to find it, because today's a Pythagorean Theorem lesson. Because look, I have a right triangle right here. So I'm going to put an x here. So I can do a squared plus b squared equals c squared. So I have x squared plus 4 squared equals 5 squared. X squared plus 16 equals 25, because 4 times 4 is 16, 5 times 5 is 25. I want to get my x squared by itself, so I'm going to subtract 16 from both sides. So I get x squared equals 9. And now again, the only way to get rid of that square, take the square root. So square root, I get x equals 3. So that means my missing side length is a 3. So I'm going to go back to my image and put a 3 in. And I need my base, so I know 4 plus 3 is 7. That's the length of my whole base. So now I'm just going to do 7 times 4, which is 28. 28 divided by 2, which is 14. So your area is 14 units squared. And that's your final answer. If you have any questions, please email myself or Miss Daniel. And remember, Miss Daniels offers extra help during second period on Mondays, Wednesdays, and Fridays via Zoom. Have a great day, ladies.